that we've successfully tethered our camera to our computer, we're backing up images. They're going to a folder on my desktop called Tethered. Inside of that tethered folder, you'll see the two sessions, the RGG EDU session from Lightroom and the RGG C1 session from Capture One. I need to get these off the computer in the event that the hard drive inside the computer fails. While we're out working on a job, if that fails, I lose all the images and the day is wasted. So we need to set up a technique to do that. And I'm going to connect this USB 3 drive, and we're going to automate the process so that I don't have to stop what I'm doing and manually copy those files to the external drive. On a Mac, we do that with an application called Carbon Copy Cloner. There are Windows equivalents, and we'll put those in the iBook for you guys. So we're going to open Carbon Copy Cloner, and we have a new task here. First thing I'm going to do is label this, and we're going to call this backup: 00, because we're going to back up on the hour every hour. Next thing we're going to do is select our source. From our desktop, we're going to choose that tethered folder, and I want to back up everything in that tethered folder, because if we move from one job to another before we have a chance to download the images that are backing up to our computer or the external drive, I want to make sure everything's backed up. So we select that, then we choose our destination. In this case, it's going to be that external drive, drive 4, and then we're going to choose how often this process runs. This window, the most often that Carbon Copy Cloner will allow us within their presets to set a backup is every hour, or on an hourly basis. In this case, I'm going to set it to happen on the hour. We'll set it for, I don't know, 12 o'clock a.m. It'll start. And it's happening every hour. We're going to have it wake the system from sleep. If we happen to be on set and we're styling a set or playing with props and the computer happens to go to sleep, we want it to wake the system back up and run that backup for us. We don't want to miss an opportunity to back up. So we'll hit done. We have that backup: 00. It's backing up every hour on the hour. We'll save that, and then we can start our clone process manually right away. It backs up all those files to our external drive. Now, if that's not enough for you and you want to back up more often, I back up every half hour. So what you do is create a second task inside a Carbon Copy Cloner pretty much the same way. I'm going to call this one backup: 30, because we're backing up on the half hour. Again, I'll choose my source, which was desktop tethered folder. We're going to go from there, select our destination, which is drive 4. We're going to ask it to back up on an hourly basis, and this time we're going to start it at 12:30 a.m. Again, waking the system from sleep if necessary. We hit done, we hit save. We just cloned it. We don't need to clone it again, but it's not going to hurt. So now we have two tasks in here: one to back up every hour on the hour, and one to back up every hour on the half hour. That means we're getting a backup every 30 minutes. You can set this up as often as you want. You can do it every 15 minutes or every 5 minutes for that sake. But I find that at my pace for shooting, every half hour pretty much gives me a pretty solid backup for all the images that I'm capturing on a set. So that's Carbon Copy Cloner. Now that we have the data on our external drive, when we get back to the studio, we need to get that off of the external drive to a large capacity storage device. And we have a couple options there. This is a G-Tech RAID system, which has 4 drives in it. This is an OWC RAID system, which also has 4 drives in it. Both of these devices connect via Thunderbolt 2 to the computer, which is a very fast connection. It's 20 gigabits a second. There's also Thunderbolt 1 connections or USB 3.0 connections. Your computer is going to dictate what type of connection you can use. Faster, of course, is better. What is a RAID system? Well, RAID gives us the ability to use multiple drives and increase our overall storage capacity. This one in particular has 24 terabytes of storage, and in a RAID 0 configuration, that storage would be seen by the computer as one solid single drive. We'd have 24 terabytes of total storage. The problem with that is it doesn't give us any kind of security or redundancy in case something happens to one of the drives. If one of the drives fails in a RAID 0 configuration, we could lose all our data. So the next option would be a RAID 1 configuration. And RAID 1 cuts that total volume in half because it takes what's on half of the system and makes an exact mirror duplicate to the other half of the system. This is the most secure, but it also uses the most space. As I said, as a 24 terabyte drive, we'd only have 12 terabytes of storage in a RAID 1 configuration. Up from that is a RAID 5 configuration. RAID 5 also uses a span across all the drives in the system. However, it writes the files in a manner that gives us some redundancy in the event of a drive failure. If one of these drives fails, there's enough information on the other drives to rewrite the missing data to a new drive. As far as storage is concerned, in a RAID 5 configuration, you're only going to get about 75% of the total capacity. So on a 24 terabyte drive, we're going to end up with approximately 18 terabytes of total storage capacity. But it's a worthwhile trade-off to have that security of hardware failure inside the device. Both of these devices do basically the same thing. The G-Tech drive is a little bit faster with read-write speed, so if you're shooting both photos and video, it may be the better option for you. The OWC drive is significantly less, so if you're only doing still photography, then this is probably the way to go. We talked about these RAID systems and how RAID works. The drives that are in these are mechanical drives. They're large capacity. These are 6 terabyte drives. In an ideal world, we'd be using SSDs for everything. We have an SSD in the computer, which gives us the fastest speed for reading and writing during our tether. We have the option of SSDs in our external drives. This one is not. This is a 1 terabyte mechanical drive. But in our large capacity devices like this, SSD is cost prohibitive, and there's size limitations as well. So we're using 7,200 RPM mechanical drives in these devices. You can get 5,400 RPM drives, but obviously the 7,200 are faster. It's going to give you a little bit better response from the drives in these enclosures. The next thing we need to do is get some sort of off-site redundancy for these drives. Ideally, a perfect backup strategy is a 3-2-1 system. That's 3 copies on 2 types of media with 1 off-site. Well, we have 1 copy here. We need to figure out a way to get a second copy of this data and get it off-site. So what we do is use a cloud backup solution like Backblaze or CrashPlan. These are systems that allow you unlimited space in the cloud that you can connect through your computer and back up not only what's on your computer, but what's also on these large capacity drives to the cloud. There's minor differences between those 2 services. The Backblaze is a native application that can run on the Mac, and the CrashPlan runs through Java, which is a little bit more resource intensive. That sounds like a win for Backblaze, but CrashPlan also offers the ability to back up a network attached device, whereas Backblaze only allows you to back up devices that are directly connected to the computer. So based on how you have your system laid out, you might have the decision made for you on which one of those services is best for you. So that gives us 2 copies, 1 off-site. We need to get a 3rd copy of that data. Now, we can either do that by having an exact duplicate of a large capacity storage device like this, that we can use Carbon Copy Cloner on-site, can make an exact replica, or we can use another off-site storage solution. One of the ones that we like is Amazon's Glacier. It's 1 cent per gigabyte, and it's on Amazon servers, which have tons of redundancy. They're very secure. At 1 cent a gigabyte is a fairly cheap solution for storing your data. The downside to that is that recovering the data from Amazon Glacier can be very expensive. So I would recommend that as your 3rd copy of your backup of your data. Pulling the information back off of Amazon on a regular basis can get very expensive. So that gives us our camera shooting tethered into our machine. We're shooting into a tethered folder on our internal SSD. We're using Carbon Copy Cloner to copy every half hour to our external drive. When we get back to the studio or we're done shooting in the studio, we take that external drive and we copy the information to a large capacity device like one of these. We can use Carbon Copy Cloner to either duplicate this large capacity device locally, or we can use Amazon Glacier as an archive for this large capacity device. Additionally, we'll use a cloud service like CrashPlan or Backblaze to get our cloud backup of this data that we can access in the event that one of these goes down. We need to recover some files, or if a file is lost or corrupted, those cloud-based options are a great easy way to recover lost or missing data. Now we're making all these backups, but the one thing we didn't cover was making a backup of the computer itself. There was a time when I was out on location and I got lazy and I didn't set up the backup external drive. And when I got back to the studio, I decided to copy the files from the local machine to our high capacity storage device, but rather than copying them, I moved them. I was tired, it had been a long day. I just used the move command and the files got corrupted in that transfer. And normally I would have lost all the files and I would have been calling the client to reshoot the job. Fortunately, because we have Time Machine connected to our router and it backs up wirelessly, as soon as I got back in the studio and opened the machine, it started backing up all those files and I was able to recover the files from Time Machine. If I hadn't done that, we would have been in a world of hurt. So I encourage you to think about your backup solution, get that 3-2-1 backup strategy in place, and you'll be good. So that's my backup strategy. That's what works for me. Hopefully you can incorporate some of that into your backup strategy.